Now that we've talked about what radicals are, we're going to be looking at the difference between something called an entire radical and a mixed radical. So an entire radical is going to have the form where we've got the root of n where the radicand is b. So basically what that means is we have our index, but the only numbers that we have aside from the index are all underneath the radical symbol. Okay, so this is different from a mixed radical. A mixed radical has a coefficient in front, and then we've got the index of n, and we're taking the root, the nth root of b. Okay, so an entire radical basically has all of the numbers contained underneath the radical sign. A mixed radical has some numbers underneath the radical sign, but then also a coefficient multiplying it in front. Okay, so for example, I might have something like, we could say the square root of 75 is an entire radical. Or we could have, the fourth root of 17. Those are entire radicals because everything is contained underneath. A mixed radical could be something like 5 times the square root of 3. That's a mixed radical because the square root of 3 is being multiplied by 5, so that's the coefficient that's sitting out in front, right? And it could be anything. We could even have something like 5 times the fifth root of, we'll say 2. Okay, those are all mixed radicals. Now it's possible with a mixed radical I can have a negative in front. So I'm allowed to have a negative as part of my coefficient. We have to be careful with those negatives. Sometimes we can actually include them underneath the radical symbol. Sometimes we can't, but we'll talk about that a little bit more. So what we're going to be doing is we're going to be looking at changing an entire radical into a mixed radical. Okay, so I'm going to start off with something like, let's say the square root of 60. Okay, so we talked before, we said there's lots of different ways that we can change 60, because we just need to find two factors, right? So I could do 2 times 30, or I could go 4 times 15, or we could go 6 times 10. I forgot 3 times 20. We could do any of those. But the only one that's actually going to help us change it from entire to mixed, the only one that's actually beneficial to us is this one here. And this one is helpful because 4 happens to be a perfect square. So watch what happens with this one, is if I rewrite it as the square root of 4 times the square root of 15, right? From our last video we said as long as they were both factors, we could split them apart and they could be under their own radical sign. Well, the square root of 4 is really just equal to 2. So instead of writing that as the square root of 4, I'm going to simplify it and write it as 2. Now I'm still multiplying by that square root of 15, okay? But now I've brought a number in front, so I have a coefficient of that radical, okay? So what we're doing is we're taking 60, and I'm rewriting it as the square root of 4 times the square root of 15, and that's going to give me 2 times the square root of 15, okay? This one is what we would call a mixed radical in, just like we would with fractions, we would say this one is in simplest form. It's in simplest form because when I look at the radicand, there are no more perfect square factors of my radicand. The only factors I have for my radicand are 1, 3, 5, and 15. None of those are perfect squares, so I can't take anything out of that further. Okay, so that would be our entire radical changed to a mixed in simplest form. Let's do a couple more. Let me try this one. You can pause the video, see if you can do it on your own. So let's go with the square root of 54. Okay, so if you want, you can pause it now, and then I'll give you a chance to work it out yourself. All right. So hopefully you looked at all the factors of 54. You figured out the biggest factor was 9. That is a perfect square. So that gives me the square root of 9 times the square root of 6. Square root of 9 is 3. So now I have 3 times the square root of 6. Okay. Another one, we'll get a little bit bigger number here. Let's go to 200. Okay, 200. If you want, pause the video, take a second to do it on your own. Okay, so for 200, the largest perfect square factor would be 100. So I can write 200 as 100 times 2, and then the square root of 100 is 10, and I get 10 times the square root of 2. Okay, so that's changing an entire radical into mixed. That one's nice and easy. That one comes pretty naturally. Where we start to run into some problems is when we try to go backwards. So I want to go from a mixed to a entire. Okay, so what we're going to do with this one, so let's say I have something like 10 times the square root of 3. Okay, what I want to do is I want to move that 10. I don't want it to be in front. I need it to move underneath the radical symbol. Okay, well, in order for 10 to move underneath the radical symbol, it also has to have a radical in front of it. So I would have to go like this. I would have to say the square root of 10. But that's a problem, because if I change 10 to the square root of 10, those are not the same number. It still has to have the same value. So this still needs to equal 10 when I move it here. The only way it's going to still equal 10 is if I square it, right? So if I take 10 squared, I would have 100. And then if I take the square root of 100, I still have 10. So what I'm doing is I'm taking the coefficient, I'm putting it under the radical symbol, and the radical sign, and I am also squaring the value. Okay, so now I have the square root of 10 squared times the square root of 3. So I still have something that is completely still equal to what I had before, right? Because 10 squared is 100. When I take the square root of 10, I have that coefficient of 10 still. Okay, well, the square root of, we'll say 10 squared, that's 100. And now I've got times the square root of 3. Now that they are both under a square root symbol, I can multiply the two things together as one radicand underneath the one symbol, and I have the square root of 300. Okay, that one doesn't seem to come as naturally to most kids as going from entire to mixed. It really is just the opposite process of what you've done, but it does seem a little bit weird to square and square root it at the same time. We'll do a couple more just so you can get the hang of it. Let's say I got 6 times the square root of 2. So if I did this one, if you want to pause it for a second, give you a chance to work on it. So what I would need to do is I would need 6. I would need to put it under a square root symbol, but also because it still has to have a value of 6, the square root of 6 does not equal 6, but the square root of 6 squared does. So I'm going to write it as the square root of 6 squared times the square root of 2. That's the same thing as the square root of 36 times the square root of 2, and that's the same as the square root of 72. Okay, let's try a harder one. I'll throw in a fraction as the coefficient. Let's see what happens with a fraction. Okay, so if I've got 2/3 times the square root of 18, I need the 2/3 to go underneath a square root symbol. But I would also need to square that fraction. Okay, so I've got the square root of 2/3 squared times the square root of 18. Now, because of my exponent laws would tell me that I would need to take the square, or I'd need to square the numerator to get 4, and square the denominator to get 9, and then I'm multiplying by that 18. I can put that all under one radical symbol, and now I've got 4/9 times 18. I can do a little bit of cross-reducing there, find out that I get a 2 and a 1, and that leaves me with simply the square root of 8. Okay. Same thing if I was to do it with a decimal. Try one with a decimal. Okay, let's go with 0.4 times the square root of 75. So, two options. You can work with the decimal if you want. I would always recommend changing it to a fraction, but I'll do it with the decimal just to show you that it's okay. So I'd have to go 0.4 squared, and then take the square root of that, multiplied by the square root of 75. That ends up giving me the square root of 0.16 times the square root of 75. And now the problem with that is you probably need your calculator to go 0.16 times 75. It does give you 12. Okay, but I would have done it maybe by changing this into 2 over 5 times the square root of 75. Because now I'm going to have the square root of 2 over 5 squared times the square root of 75. That's the same thing as the square root of 4 over 25 times 75, all under that radical sign. Using my cross reducing, that becomes a 3 and a 1, and I get the square root of 12. Okay, so again, up to you how you want to do it, but I would probably change my decimal to a fraction if I could, so then I can avoid using the calculator. All right, one last one. I'm going to show you with the negatives. Let's say I had a negative coefficient here. So because my index here is, I didn't write it down because it's a 2, because my index is a 2, I am not allowed to bring a negative underneath that radical sign. Okay, so I have to leave the negative sitting out front. So I'm going to just leave the negative sitting out front, and then I'm going to write it as the square root of 7 squared times the square root of 5. So that's negative, and then the square root of 49 times the square root of 5, and that's negative times the square root of 245. So I'm just leaving the negative out in front. Okay, if you don't believe me, try at home. If you had tried to bring the negative in and you end up deciding to work with it as the square root of negative 245, try typing that into your calculator, but be careful that you don't set your whole house on fire, right? If you try to take the square root of a negative, calculator fires may and or may not happen. Probably not the best time to be setting your house on fire by trying to take the square root of something that's negative. Okay, we've talked about this in class. You can't take the square root of a negative unless you are working with that imaginary number I, which is equal to the square root of negative 1. Remember, that's imaginary, so we don't actually get to use that until much further on in your mathematical careers. Okay, so if you've got a negative and you've got that index of 2 in front, just make sure you leave the negative sitting outside. I know it doesn't seem like an entire radical because you think there's still a coefficient, but that negative is not allowed to travel inside. And I know you're going to see a couple examples of that in your books, and I didn't want it to mess with your heads. All right, have a good week, you guys. Bye.